Alright, in this lesson I'm going to go over isolating a variable when it's within an equation that has many other variables. It's just like solving equations. It's just instead of having numbers in there to get rid of, you got to get rid of letters. So in this case, number one, we're going to isolate the n. That means we have to get rid of w and r. So to get rid of w and r, I just work in reverse order of operations. Get rid of the adding and subtracting first. So we're going to get rid of the w. Subtract over the w. That'll leave me with Rn equals b minus w. And then I've got the r next to the n. That implies it's r times n. So we're just going to do the reverse of multiplication and divide over the r. Now, a couple things you can do over here. One, you can just divide the whole thing by r, or you can divide them each individually by r, up to you. Probably the cleanest answer you can leave would be n equals b minus w over r. You've now isolated the n. Example 2. Okay, this one I've got a couple things in front of the n. You might be tempted to distribute the n, but you don't want to distribute the n because what would that would cause an extra n to be there. You'd have an and bn, and then you'd have a problem. So if I want to get a letter alone, my goal is to make it so that letter only shows up once. So right now the n shows up once. That's what I want. So I just need to get rid of the things that are on that side with the n. And the things that are on that side are this 2/3. But also what's on this side is this a plus b, which I can just think of that as some number. You know, a plus b, maybe it equals 5, maybe it equals 6, 7, whatever. I'm going to move that over all one shot like it was some number. So first off, I'm going to get rid of the 2/3. It's 2/3 times. So to get rid of the 2/3, let me erase these. To get rid of the 2/3, I'm going to multiply by the reciprocal, both sides. Now that will get rid of the 3's and the 2's on the left and leave me with a plus b in parentheses, so that quantity times n. But on the right, I have to make sure and multiply everything on the right, or the whole side on the right. So just like up above, I said you could divide the b and the w individually by r. You could multiply the b and the c individually by 3/2, or you could simply put the 3/2 next to the b minus c in parentheses. So put quantity b minus c. Okay, so now I've got a plus b times n, and like I mentioned earlier, that's just like having some number times n. You know, a plus b, that could, you know, let's say that equals 7. And if this was 7n, I think you'd all say, oh, let's divide by 7. That would be the right way to handle it. Well, it's not a 7, it's an a plus b. So we just divide by a plus b. Divide the whole side on the right by a plus b, and we're almost done here, almost good to go. The one thing I don't like on the right-hand side right here is that I have a fraction in a fraction. I've got 3/2 in the numerator. So what my preference would be is to write that instead of 3/2 in the numerator as 3 in the numerator. So I get n equals 3 in the numerator. Leave the b minus c in the numerator. But if you were to do the simpling, that 2, that would actually, it's the simplifying, that 2 would actually end up out of the numerator and be in the denominator. This is the cleanest, or one of the cleaner answers that you can leave for this particular problem. If you need more tips on why that 2 drops in the denominator, make sure you ask me before, after school, or in class. Example 3. Here I'm trying to get n alone. I got big plus tiny equals tig. And again, there's only one n, so that's good. Makes it pretty easy when there's only one n. I need to get rid of the big and the tiy. Well, the big is being added on. And again, big might just be some number. You know, if b was 2, I was 3, and g was 4, big would end up being 24 because you'd have 2 times 3 times 20 times 4 is 24. And if big was 24, you'd end up subtracting the 24 over. I don't know what BI and G are. I just did that for example to hopefully get you to understand that BIG is just some number. So what we would do then is subtract that number over, or in this case we could just subtract BIG over. So now I have tiny equals TIG minus big. Okay, now we've got to finish up isolating the n. I got to get rid of the t, the I, and the y. Well, what's happening here is the t, I, and y are all being multiplied onto the n. So I can divide them over individually, but it's a lot quicker just to say, you know what, I'm going to divide by t, I, and y right away. That'll cancel and leave me with n equals. And if I divide by t, I, and y on the left, I need to divide the whole right side by t, I, and y. So if you left me the answer TIG minus big equals TIY, that's a pretty good answer. You could simplify it a little bit more. We'll be doing more of that throughout the year. The simplification that I would like to see out of that is to recognize, hey, these all have an I in them. So rather than leave I in every single term, because they all have an I, you can take that I out. TG minus BG all over TY. You might be thinking, well, can't we take the T's out because there's a T here and a T here? And the answer to that is no, because there's no T over here. I can't take out those T's. It has to be in each and every term. So what's really happening there, let me get rid of those marks there. What's really happening is, if you remember back in earlier algebra when you factored, we're really factoring this here, saying that on the top, I could have taken out an I. Well, I could take out an IG for that matter. I could have said they both have an IG. IG. And then that leaves me with a T minus B all over TIY. And then because IG has got multiply next to it, no add subtract. And down here, this I has multiplied by it, no add subtract, you can cancel these i's out. So that's what we're really doing when we're saying you can take a letter out of each and every term. Alright, example 4. Example 4 is a little bit different because you've got two n's and I wanted you to isolate n's. So this caused a little bit of problem. Unless you realize what I just showed you, you could factor out an n. So we're going to factor out an n and say that f sub 1 n minus f sub 2 n is the same as n times the quantity f sub 1 minus f sub 2. Once you recognize that step, it's pretty simple. You just say, all right, I'm taking n times something. So what do I need to do to get rid of that something? I divide by that something, the whole thing. So leave an answer of n equals f over f sub 1 minus f sub 2 would be a great way to go there. No canceling can be done there. You might say, oh, they're all f's. No, they're not. There's a difference between the f and the f sub 1. That's because it's got the sub, that tells me it's not the same as the regular capital. And the other, and I had a capital F anyway, so they're not the same, can't factor it. There's our final answer. Okay, example 5. Example 5, I've got fractions. So what can I do here? Well, I've got adding with fractions, and well, I guess I'd add those together because they add fractions that need a common denominator, and lo and behold, I do have one. So I can go ahead and add the numerators. We've worked on adding like terms already. 2cn plus 5cn is 7cn, and then we don't change the denominator. Okay, so the goal is to get n alone. So I need to get rid of 7, c, and 3. You can get rid of them one at a time. You can get rid of them all at once. I'm going to get rid of the 3 first just to emphasize how you get rid of the 3, because for some reason, students struggle with getting rid of the 3. I don't know if we just don't give you enough practice as math teachers or what. We're very comfortable getting rid of the 7, and the c. We know to divide, but then a 3 comes around, huh? Well, that's divide 3. So what's the opposite of divide? Multiply. And that'll cancel over here, maybe it's 7cn equals. This would be like 3 over 1, so it's 3r over z. The 3 goes in the numerator. Now, I've got 7cn. I need to get rid of the 7c, and we've done this before. You're going to divide both sides by 7c. Well, this ends up looking to be kind of a mess, because you got a fraction and a fraction again. I don't want that. So, at some point, I want you to recognize that it just simply ends up in the denominator. I'm going to show that to you right now. So what I have here is 3rz divided by 7c. Well, when you divide fractions, maybe remember you need to multiply by the reciprocal, and we could have done that over here. We're going to multiply by 1 over 7c right away. Now it's easier to see that 7c just simply goes in the denominator. So what's our final answer on this one? Now let me clear this out here. Our final answer then should have been n equals 3r over 7cz. So when you divide a fraction, you take a fraction, divide by something, that something is just going to end up in the denominator. Okay, last one. Quite complex because we're going to solve for n, and there's an n here and there's an n here. So what we need to do is get those n's on the same side of the equation. In order to do that, in this particular problem, I'd say let's use the distributive property to get rid of these parentheses. So 3 times 2mn is 6mn. 3 times negative 4b is negative 12b. On the right-hand side, we do distributive property and get 10c plus 5dn. And I said I want you to get the n, the expressions or the terms with the n's on the same side. So what we need to do is bring the 5dn over to the left or the 6mn over to the right. I guess I prefer to bring the 5dn over to the left. So I'm going to subtract that over. And that would leave me with 6mn. I'm going to put the minus 5dn right there. I still have the minus 12b, and that equals 10c. The next thing I'll advise you to do is to make it so that the terms that don't have the n's that are on the same side. So we could have done this all at the same time, but I didn't, so I'll do it here. I'm going to add the 12b over. So 10c plus 12b. And hopefully you've done enough working with equations now that you realize that if there's a term on the left, to move it over to the right, all you gotta do is switch its sign. So if you move over to the other side of the equals, you change your sign. You've changed your viewpoint. If you're a Democrat, you decide to become a Republican, it's like you've changed your attitude, you've changed from a positive to a negative or vice versa. That's how the analogy I make to that. Okay, so now on the left, I've got terms with n's in them. Now I do my move that I did here in a previous problem. I take n's out, factor out an n. And then finally finish it off by isolating the n. This is n times some quantity. This quantity could be any number. So all we need to do is divide that any number over. In this case, our number is the expression 6m minus 5d. So n equals 10c plus 12b over 6m minus 5d. Is a good final answer because I don't see anything that can cancel on the right. They don't have any common terms. Thanks for watching. Have a great day.